Hello students, in kinematics, if we talk about motion in two dimension, first we need to understand about scalars and vectors. So now the upcoming videos will be solely based upon vectors and scalars, and later on we will come back to that motion in two dimension, and once again we are going to study about velocities, acceleration and all. Okay, uh, the word vector is widely used in other studies also. In biology it is the carrier of some disease, in computers it is software for designing, but in physics it has uh, a specific meaning related to physical quantity. So, in physics, we can classify physical quantities into many categories, but here I am categorizing them as scalars and vectors. So, scalars, the physical quantity which need only magnitude to be specified. Sometimes people think that scalar quantities have only magnitude and no direction, but that is not true. Scalar quantities can also have direction, but uh, their direction need not to be specified. And other thing is also their direction uh, is not that much sensitive that of vectors. I will explain you by some example later on, but their direction won't affect their observation uh, in that manner that the direction of vectors affects. So scalars have magnitude. They can have direction, but we require their magnitude only for their specifications. Okay, now vectors. A physical quantity is said to be vector it if if it has magnitude, direction, if it follows vector addition law, the law of vector addition, and there is a fourth condition also, its vector addition is commutative. Well, actually vector addition is commutative, but if there is a physical quantity and we are considering its vector addition, but its vector addition is not commuting, then it won't be called a vector quantity, though it is fulfilling all other conditions. So uh, we'll talk about this condition in rotational motion. I'm not explaining it right now here, but in rotational motion, this thing right now it is meaningless. It looks like meaningless term, meaningless phrase, but then it will be a meaningful phrase. Okay, so scalars, some of the examples are time, though time has a conventional direction that it moves from past to future. That looks like philosophical. Electric current, It also has direction. It flows from high potential to low potential. Heat flow. It also has direction from hot body to cold body. But all of these quantities have magnitude, direction, but their addition, they don't follow the vector addition rule, so they are scalars. Other than that, we have mass, we have density, we have distance, we have speed, work, energy, pressure, plane angle. So list is long, and you can make a list, and in upcoming chapter there will be lots and lots of other physical quantities. You can uh, just fill it in your list. Okay, vectors like displacement, velocity, acceleration, momentum. There are two types of momentum: linear momentum. So angular momentum, force, torque. In fact, angular displacement, angular velocity, angular acceleration. There, later on, you will come to know about gravitational field intensity, electric field intensity, magnetic field intensity. All of these have direction. So, uh, these quantities have these quantities are called vectors, and again its list is also long, and right now I am just ending this list here. There is a point of conflict that I have written plane angle here, and there is some angular displacement here. Are they same or are they different? So it is it depends upon their nature. um, what is that angle is all about. This is if something is turning, then it is angular displacement, then we will measure angular displacement. Okay, and again this angular displacement can be vector as well as it can be scalar depending upon its size. If angular displacement delta theta tends to 0, then it will be called vector, but angular displacement delta theta for larger values is considered as scalar. So these things later on will be revealed to you. Why is it so? So this is all about the concept behind vector and scalar and different quantities which we can categorize as vector and scalar. Okay. Now, next thing, representation of a vector. How are we going to represent a vector? How are we going to symbolize a vector? So, if we have a physical quantity, a vector physical quantity A, then its vector form is given by A and an arrow over it. Sometimes it is difficult for publishers to publish this thing, uh, writing an alphabet and putting an arrow, so they just write it in bold letter and they say that if it is written in bold letter, then it is vector value, and if it is written in normal letter font, then it is a scalar value. So this is its vector form, and if we put a mod on both side, I mean put the mod on this vector value, then it is a scalar value, then it is just the magnitude, just the number. Other than that, we can directly write it like this also. So a vector form, if we want to show it in a vector form, we have to put an arrow over it, and if we are interested in its numeric value only, its magnitude only, so either we, or we can directly remove that arrow. Both symbols are representation of magnitude, that is numeric value only. I prefer this, but keep this thing in your mind also. Okay. Other than that, there is graphical method. In graphical method, we show by length of and direction by arrowhead. So if I have a force of 5 Newton and its direction is toward right according to this plane and parallel to ground, then first I will select, like we used to do in geography, I have to select some unit for graph, how much unit I am taking for 1 Newton. So let us suppose this is the I am taking 1 Newton, so I have to take 5 such lengths, 5 unit of such lengths, 1 unit, 2 unit, 3 unit, 4 unit and 5 unit. This is its initial and this is its terminal point. Its length is indicating its magnitude and its arrowhead is indicating its direction. But we just draw it schematically when we just represent some physical quantity. So this is how we are going to show a vector. If this A is a vector and this is its magnitude and its direction, then a vector greater than this will definitely have. So if B is greater than A, then it will be longer than that. But they can have different direction, yes, of course. And this we represented M. Uh, if this is A, then minus A will be just opposite to that. Magnitude same, direction is opposite. This is how we deal with these vectors. So how are we going to analyze these type of vectors, and how are we going to use them in our daily life? So we will see in next video.